do your training in the worst weather possible. So when you have a good day, you don't take it for granted. Alright, so here's my new handy-dandy voltage chart I made. Let's see. I'll read all these in separate one. Preferred voltage, preferred. Let's see. 13.8 preferred. 69. 115, 230, 500, 765. Let's see, 7200, 12470. Let's see. This one, 13.8. That's pretty much your preferred voltages there. So, let's see. First, we got your 120, single phase, low voltage. Then you got your 120, 240, 480, 600, low voltage. There's your 120, 208, commercial, 277, 480. 3470, 600, that's your industrial voltages. All of these are three-phase, except for these couple up here. Then you got your medium voltage, 2400, 4160. 4160 is your preferred, 4800, 6900. 13.8 is preferred, 2300, 34,500, 46,000, 69,000. Let's see. Oh, look at this, I'm just playing it. Yeah, he's like a little bit of stuff. Oh, it's gonna load on the engine. Let me yaw that back end up here. The roll, the pitch, the yaw. I mean, he's like all over the freaking place. Oh, listen to that load and crease on the engines. Headwind. Please don't stall, please don't stall. He's like a little bit like that. Yeah, pitch, roll, yaw. I mean, oh yeah, he's battling pretty good. He's like yawed out. Let's see. Oh yeah, you listen to that load in the engine. Yeah, he looks like he's good. He's got plenty of speed for that headwind. Right, so back to this. You got your 13.8, 46,000. Actually, 69,000 starts your high voltage. Hold on, zoom out. Yeah, you can zoom out. Your high voltage is your 69,000, 115,000, 130 kV, 161 kV. Then you got your extra high voltage, which is actually 45,500, 765. I gotta fix this chart. Yeah, it starts. Power you need, the bigger everything's going to get. And then you got your industrial this is your preferred voltage, 7200, 12470, three-phase. This is pretty much your all this stuff was devised about 100 years ago. Reclosers are typically three-phase voltage. Basically, it gives all your wires three chances of clear fault, and if they don't, it's short circuit. Typically, you have your section analyzer there. So your single-phase voltage, two chances for clear to win the power. But if it does trip, then you got this bypass disconnect fuse there. So that way, you can take the service, put the fuse there, the fuse will protect the line, and you can inspect the circuit breaker. And then you switch to the line, Then we come over here to my storm damage example. Basically, I put the insulators on there with some short cords. And insulators up top. And I put my ground on top. So it goes from there up to the top. And I got my guy wire here, which this should have ground wire connected to here too. I basically got my 45-degree guy wire. I got that guy wire going straight on that way. And I got this one at 45 degrees. Because I'm short of parts. I don't have enough parts to put two guy wires. One here, one there. Plus, I only have one of those braces, so there's one brace on each pole. Which is storm damage, which you do for short parts. Like I said, get used to the bad weather, because that's the only time these things will fall, and then you're going to have to fix them. And all the loads just make the power go all over the place. The wave's not smooth. It pretty much eliminates the power charges. I mean, you get the bottom part up, the top part pretty much keeps the voltage the same. Basically, this is and it causes a voltage surge. And honest to God, you can have about 30,000 volts coming out of your wall socket when you disconnect power. If you've ever pulled a vacuum cleaner out of the wall and you saw that arc, that's about 30,000 volts. Well, it could actually go up to about 100,000, depending on how much inductance there is. I mean, you've all seen that when you pull something on the wall and it sparks. I mean, basically you got your power factor capacitor with this fuse. So the fuse to protect it in case it gets overloaded. The fuse suddenly sparks. I mean, then you got your butt ground in this pole going up there. Now you come over here, unfortunately, I don't have this one done yet. This will be around 2240, single phase. Going to the meter socket. Basically, you'd have your single phase power, come up there to a step down transformer, and it would step down to 7200 to 12240. Basically, this wire. Basically, the transformer is like 3 coils. We'll come down here and show you that. Actually, I'll come down here and show you that. Yeah, just like ignore all this mess out here. That's a whole other thing there. That has nothing to do with the power line. I got this pole down here so you can see the background. I will show you these tab connections in a second. I'll tell you what, bottomless bucket. Got your hole, the smiley face. The bottomless bucket just allows you to dig without all the work. Got the smiley face. Get the $20 or $100 bill for getting to the top. Sign your name in there. You can see the butt ground just wrapped around the pole like that. Staple to it. You got your first row. Each one gets you about a grand. This is a 725 pole. Typically your utility poles are 345. So basically, this would be your 7200 would be on here, connected to ground, and your 12240 would be coming out of this one. Basically, you would have 240 from here to here, 120 and 120 like that, and this would be grounded as your neutral. Basically, step up transformer, step up transformer. You see what I did there? You got your little power plant there. I'll tell you what, you can see how we're doing this. Like I said, you gotta train in the worst weather possible. So on a good day, you don't take the good day for granted. And I'll come over here and show you how it works. Here's my 122 and you see how it works. But then if you need slight industrial, you use and basically it's your 240, 240, 240. then you get your high leg, the 208, which, you can see how that works. But then if you need three-phase power, 120, 208, three-phase, like your light industrial, high commercial, you got that. Basically 3 transformers connected like this, step-down transformers, and there's voltage drops, 208, 120, you can see how that works. Neutral in the center, that's a Y connection. Then we got delta high leg, which is, let's see, sorry, language. 120, 240, three-phase, delta high leg. It's like your neutral on your 120 watt, except it's connected like that. But this one, don't touch a neutral or anything else because you touch a neutral, you're going to get shocked by, I think it was like 208, I can't remember. I tell you what, I can't read that, I can fix this crap. Then you got your industrial, they're high industrial, which you can go up to 4160, but that's a weather rating. You can see how that's connected. Which is not a good thing